Let's solve one previous question of graph theory. This question was asked in GATE CS 2019, question number 12. Let G be an undirected complete graph on n vertices where n greater than 2. Then the number of different Hamilton cycle in G is equals to, and 4 options are given. So the graph is a undirected complete graph having n greater than 2, and we need to find number of Hamilton cycle. Hamilton cycle is a simple circuit that passes through all the vertex and return to the starting vertex. Means we are visiting every vertex exactly once. And in the question, it's not mentioned about whether the graph is leveled or unleveled. Suppose let's take a unleveled graph having 3 vertex. This is a 3 vertex complete graph. Now suppose we'll start a Hamilton circuit from this, like we'll visit this vertex, then return to this. And suppose we'll start from this, we'll visit this vertex and we'll return to it. And suppose we'll start from this vertex, we'll visit this vertex, then this, then return to this. So there are different Hamilton cycle possible, but as the graph is unleveled, so every Hamilton cycle is considered as a 1. So if the graph is unleveled, every vertex are identical, and as every vertex are identical, so number of Hamilton cycle possible equals to 1 in case of unleveled complete graph. So from this option, one option is true, that is C, when the graph is unleveled. Now check for leveled. In an undirected complete graph on n vertices, n permutations are possible to visit every node, right? But from this permutation, n different places you can start. Suppose there are 4 vertex A, B, C, D, and it's a complete graph. So every vertex are adjacent to every other vertex. Then there are 4 different places, like you can start from A or start from B, start from C or start from D. And there are also 2 different direction you can travel. Means suppose you are starting from A, you can visit A, B, C, D, again A, right? Or you can start from A, D, C, B, A. So there are 2 different directions. Any one of these n factorial cycle, and we are doing 2n cycles which all contain the same set of edges. That's why n factorial divide 2n. N factorial divide 2n, that you can write as n multiplication n minus 1 factorial divide 2n. N will be cancelled, so it is n minus 1 factorial divide 2. So in case of leveled graph, if vertices are named, the number of distinct Hamilton cycle possible equals to n minus 1 factorial divide by 2. So if the graph is unleveled, then number of Hamilton cycle possible equals to 1. If the graph is leveled, the number of Hamilton cycle possible equals to n minus 1 factorial divide by 2. So answer will be both option C and option D. I already discussed Hamilton cycle. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you.